Hey there, year 8s, Mr. Herman here, and this is the exercise of 5B, Substitution and Equivalence. The learning goals for this one is to understand what it means for two expressions to be equivalent, to understand how the commutative and associative laws of arithmetic can be used to determine equivalence. The success criteria for this one is to be able to substitute values to evaluate algebraic expressions and to be able to show that two expressions are not equivalent using a method called substitution. Now there's quite a few terms that we have to be familiar with, but the main goal at the end of this exercise and when tackling the questions is to be able to substitute values into an expression to get a certain number at the end, and to see if two expressions mean the same thing, hence the word equivalence. So before we get to that, one common thing to do with algebraic expressions is to replace the pronumerals or the letters with numbers. This is referred to as either substitution or evaluation. In the expression here, 4 plus x, x can be any value. Okay, it's just an expression, 4 plus x. What we're going to do is we can substitute x equals 3 to get the result 7. So what we've done is we've chosen a number, we've assigned a number for x, and in this particular case we've made x is equal to 3. When we substitute this into the expression, and substitute just means replace, when we substitute this into the expression we end up getting 4 plus 3, which we know is 7. So that's pretty much the gist of substitution. Whenever we get an expression, the letters will get assigned a number. You substitute the numbers into the expression to get to evaluate an answer. An evaluation just means to get an answer from. So two expressions are said to be equivalent or the same if they always give the same result when a number is substituted. For example, 4 plus x and x plus 4. These two expressions are considered equivalent because 4 plus x and x plus 4 will be equal numbers no matter what value of x is substituted. Now let's think about this. Let's say we replaced x is equal to 3 like we did in the first example. 4 plus 3 is equal to 7. 3 plus 4 is equal to 7. No matter what starting value you have, if you're going to add on a value to that, that's the same thing as starting with the value added in the first place and then adding what you originally started with. Kind of like a reverse roll of some sort. So I would like to think of this as if I started the chocolate bar and there are 4 pieces and I add some random amount which is x, this is the same as starting with that random number which is x and then adding 4 to it. Isn't it? You will get the same result no matter what. These two expressions are considered equivalent. Now just be careful that equivalence occurs when addition and multiplication happen. It's not equivalent if subtraction or division occurs, and we'll look into this further down the track. For now, let's look at some key ideas. To evaluate an expression or to substitute values just simply means to replace each letter or pronumeral in an expression with a number to obtain a final value. So at the end of this, when we do a substitution, we want a final value. We want this digit of some sort at the end. For example, if we assign the values of a to 3 and b to 4, then we can evaluate the expression 7a plus 2p plus 5. What we're going to do is, remember 7a just means 7 times a, and 2b just means 2 times b. So all we end up with is 7 times, now a is being assigned to the number 3. Okay, I'll actually put this in a different color to indicate what's being substituted in. So this is 7 times 3 as the first part, plus 2 times b has been assigned the number 4, and then we have this plus 5 tagging at the end. Now you got to remember your BIDMAS rules. We always do brackets first, no brackets. Indices or powers second, no powers. Division next, no. Multiplication is the first thing that we do from left to right. So 7 times 3, we work out to be 21. 2 times 4, we work out to be 8, and then we still have this 5 tagging along. So all we're doing is just substituting specific values into expressions. These are given to us and they can change depending on the question. 21 plus 8, which is 29, plus 5, this is equal to 34. So this is saying here, based on this expression, our final value is 34 if our a is equal to 3 and b is equal to 4. This value will change if a and b vary as well. And that's all there is to substitution. It's quite a simple concept. But the thing that can stump students, and I've seen it from time and time again, two expressions are equivalent if they have equal values regardless of the number that is being substituted into each pronumeral. So the laws of arithmetic, and arithmetic is just simple addition, subtraction, multiplication, division. These laws help to determine equivalence. And there's one law, the commutative law. And the commutative laws of arithmetic tells us two things. That if we were to add any two numbers, a plus b, this is the same as getting those two numbers and flipping their approach. So a plus b is the same as b plus a. And the substitution comes into play is I can choose any two numbers. Doesn't matter. Let's say a is equal to 6 and b is equal to 7. Now we know that 6 plus 7 is equal to 13. If I were to do this the other way around, 7 plus 6, this is also 13. And no matter what two values you substitute in, you will always end up, provided that they are both positive, you will always end up with the same solution. So a plus b is the same as b plus a. Remember, these are just two random letters. It could be t plus s is the same as s plus t. You can even have x plus y plus z is the same as z plus y plus x. Okay, you can have as many letters within the expression as long as they're all being added and as long as they're all positive. The commutative law indicates that this will be the same. And the other one has to do with multiplication. If a is multiplied by b, this is the same as getting b and multiplying it with a. In other words, ab is equal to ba. And again, you can choose any letter. This can be zy is the same as yz. When you substitute any two values, you will always get the same solution. Okay, this is the commutative law. Let's have a look at a few examples and I'll show you which set of questions you need to approach. First one has to do with substituting. So substitute x is equal to 3 and y is equal to 6 to evaluate or obtain the answer to the following expressions. 5x. So 5x just means 5 times x. Now x has been assigned a value, which is here. X is equal to 3. So what we're looking for, and this is the writing or the format that you put it out as, when x is equal to 3, 5x is equal to 5 times 3, so we're replacing x with a 3, and remember there's an invisible times between a number and a letter, which is equal to 15. That's our final solution for that. Pretty simple. It's almost like you're trying to figure out what 5x is when x has been given or assigned a value. X, we don't know what x is. You just got to read the question. Okay. For some reason, this is, I don't know where, but there's this weird misconception that x is always going to be equal to 1. Please, if you have this misconception for whatever reason, try to disregard it. X is a variable that can change. It can obtain any value depending on what the circumstance is or what the question is telling you. Now this one is a simple one. Let's jump straight into what seems to be a tricky one, but it's actually quite simple. 5x squared plus 2y plus x. Okay, so let's write the expression first. 5x squared plus 2y plus x. So when x is equal to 3, and now we've got another variable y, which is equal to 6. So when x is equal to 3 and y is equal to 6, let's just go ahead and put a straight substitution into it. This is going to equal 5 times 3 and this little 2 on top. Remember, x squared, which simply means x times x. So this is here is 5 times 3 squared. Okay, that's the first part, plus 2 times y, which is 2 times 6, and then we're going to add an extra x on the top of this. Okay, so all I've done is just simply replace the variables here with the numbers that have been assigned to it. I haven't really worked anything out just yet. Now remember, you got to apply your rules of BIDMAS. Any brackets? No. Any indices? Yes. Indices or index just means powered numbers. So this is going to be 5 times 3 squared, which is 3 times 3, which is 9, plus 2 times 6, plus 3. Now we can work out our multiplication. There's no division in there. 5 times 9, 45, plus 2 times 6, which is 12, plus the 3, tagging along. Now our final solution, 45 plus 12 is 57 plus 3, which gives me 60. That right there is our final solution. So the trickiest part to substitution simply is just making sure that your arithmetic is correct. Okay, and also making sure that when there's a number next to a letter, regardless of whether the letter or pronumeral has a power or not, there's an invisible multiplication in between. So just be careful. I've seen people get into the this weird habit where they do 5x and they substitute 3 into here, and they end up with the answer 53 because I've just simply done a straight substitution, not knowing that there's a multiplication in between. This right here, so no. Alright, this is incorrect. The last example before I show you which questions you need to do is we're going to decide if certain expressions are equivalent. Now, first one here, we have two expressions. We have x minus 3 and 3 minus x. And what we're doing is we want to see that these things, no matter what x value you put in, will provide the same solution. Now, I said it is commutative. I always get that word mixed up or stuff it up. Commutative, there we go. If there is addition or multiplication involved. In this case, there is subtraction. So are these equivalent expressions? Well, no, they're not equivalent. And the reason why is because if we choose an x value, let's say 5 minus 3, this is just an example as to why. 5 minus 3 will give me 2. But if I did, and that's when x is equal to 5. If I did 3 minus 5, this will end up giving me negative 2. And 2 and negative 2 are not the same. They're not equivalent. And you can try every single x value. The only x value that will make it equivalent is when x is equal to 3. That's the only time it will be equivalent, because that will give us an answer of 0. But just because one solution makes it equivalent and none of the others don't make it equivalent, that doesn't mean that the whole thing is then equivalent. You have to do it for every single x value. Okay, so in this case, this is not equivalent. No, not equivalent. B, A and B, same as B plus 2A minus A. Now, at a first glance, you would think, hey, this is not equivalent. They kind of look pretty different. I mean, A plus B is not the same. It is the same as B plus A. But this doesn't look like B plus A. But then again, it is. It's just not obvious. Let's try a substitution of A is equal to 1 and B is equal to 2. So 1 plus 2, this will give me 3. That's a downwards arrow, kind of looks like a smiley face. In this case here, B is equal to 2, so 2 plus 2 times 1, so 2 plus 2 is 4, minus another 1, which is 3. So when we do the substitution into this, hey, we end up getting a 3. Well, maybe this is a fluke. We can try 2 other values. I'm not going to do it. I know that they are equivalent only because this right here can be simplified further down. If I have 2 lots of A and I take away another A from it, what am I end up with? Well, 2A, take away another A, just leaves me with 1A, one lot of A. So this here can be written as B plus one lot of A, which is just A. Hold on a second. Isn't A plus B and B plus A the same thing? Yes, it is. So in this case, yes, this is equivalent. Okay, this is equivalent. It's not obvious, but it is equivalent. In this case here, it is not equivalent. Okay, if you see this symbol here, this just means not equal to. Obviously, this is opposite, which is equal to. Alright, here are the textbook questions. If you have the textbook at home, or you even have a digital version of it, we're looking at page 296. Exercise 5B starts there. The questions you'll be doing are 1, 2, 3, 4, and 5, all left-hand side. For question 6 and for question 7, I want you just to approach question 6, A, B, and C. And for question 7, you can do this question, but only as an extension. Okay, so to repeat this, question 1, left-hand side, 2, the 2 left-hand sides, 3, left-hand side, 4, left-hand side, and all of question 5 here is 6, A, B, and C. And that concludes this exercise for 5B. Hopefully this is the last video tutorial that you guys have to watch, and then we'll go back into school on the Wednesday. Best of luck. Bye.